gently off the far wall. And then there's images of the ball after the launch.
Here's the actual ping pong ball that was just launched in the first part of this video. Launched at 787 meters per second. You can see some faint little scuff marks.
The problem is that some of the pressurized air is able to slip past the ball and collect between the ball and the front disc. This air becomes more and more pressurized as the ball moves down the tube, providing back between the ball and the burst disc. This allows the ball to accelerate for the entire length of the tube. You can see that the ball now hits and tears the disc directly, instead of the air which is trapped between it and the disc. Now that the ball is up to nearly half a kilometer per second, what can it do? At the moment, balls hit most materials, they shatter or break through, but the dimpled texture of the paddles causes something really strange. Every time the ball hits a paddle, there is a bright flash of light, significantly brighter than any of the lights I use for filming, and of very short duration. This flash is caused by the extreme pressure and heat of air trapped between the ball and the dimples of the paddle surface.
Alright. Ready?
Yep. Oh, it's early, dang it. Wow. Oops. I'll let you watch the
Fire.
Thing faster, and I started thinking about how a supersonic wind tunnel works, and so treated this like a supersonic wind tunnel. You hook a vacuum pump up to it and you draw all the air out until you've got essentially a full vacuum in here. The air all rushes in, pushes the ball down the tube. Well, ping pong balls don't go very fast because of wind resistance, drag going through the air. Well, there's no air in there. The idea was to put a seal there and then add two pieces. One is a nozzle, call this converging diverging nozzle. This is what you see on rocket engines and supersonic wind tunnels, things like that. And the ball goes there.